Hello and welcome to NASO. We'll continue our playlist Math for Beginners, and in this video we'll cover Unit 1, Chapter 2, Algebraic Properties, which is found in the book Everything You Need to Ace Pre-Algebra and Algebra 1 in one big fat notebook. So let's begin with algebraic properties. So before we start getting into the details of this chapter, for some of you, it's probably the first time that you see this word, algebraic. So algebraic can be is pretty much stands for pertaining to algebra. Okay. To algebra. And then we have the word properties. And in mathematics, properties is basically a term used to define a law. So in other words, algebraic properties, you can define these two terms as laws pertaining to algebra. Okay, so let me actually type that in just to move a little bit quicker. I'm going to try to incorporate more typing just because it takes me quite a bit to write the words down. So laws pertaining to algebra, and let me make that a little bit bigger just so you can see that nice and clear. I'll try 18. There we go. So algebraic properties are laws pertaining to algebra. And you might be thinking, well, I didn't know that laws existed for math. Well, it does, and it just helps everyone follow certain codes or standards, right? For example, just to kind of simplify this, when we think about traffic light, think about a traffic light, right? You have your red light, you have your yellow, and then you have your green. So there's a law out there that says when you see a green light, you can go. When you see a yellow, that's pretty much prepare to stop or slow down, start slowing down. Okay. And if you see a red, you need to stop at the white line. All right, so following these laws or rules allows the flow of traffic to operate normally. And once people start to ignore these lights, that's when you can probably have an accident occur. Okay? So likewise, in mathematics, we have properties, which can be looked as laws. And these laws help us operate numbers or groups of numbers, right? So now that you have a better understanding of what is an algebraic property, let's actually start learning these properties. So we have some basic properties, right? And under basic properties, we have commutative property of addition. And it states that for any two numbers, A and B, you can add A plus B, and it is equal to like if you added B plus A. So these are equivalent numerical expressions, and this means that both sides of the math equation have equal value. Okay, so what does that mean? Here's an example. The example is 1 plus 2 is equal to or the same thing as 2 plus 1. So in this case, 1 is our A and 2 is B. And again, you can see that 2 is our B and 1 is our A. So in other words, if I were to switch these two around, they would still equal the same thing. And we know that 1 plus 2 is 3, and 1 plus 2 is 3. So just a hint, think of commute. To commute means to move around. So we can move the order of numbers around and not affect the result. So likewise, we could have put 2 plus 1. It's the same thing as 1 plus 2. Why? Because the law states that A plus B is equal to B plus A. And A or B can be any real number, right? This is just an example here, but A could be 100 and B could be 200. So 100 plus 200 is equal to 200 plus 100. Just a more simple breakdown of this. Let me just give you some illustrations here. 1 square, kind of going back to this example, okay? I'm going to kind of now draw this out over here. So I'm going to illustrate what that looks like. So 1 red square plus 2 red squares is equal to 2 blue squares and a red square. We know that this group of squares are equal to 3. It's 3 of them. And these group of squares are also equal to 3. So we can see that this law is true. That no matter how you order the variables or the numbers, one side will equal the other side. Let's move on to, we started with commutative property of addition, and now let's talk about the commutative property of multiplication. And it states that for any two numbers, x and y, just use my pencil here, that x times y is equal to y times x. So very similar to the commutative property of addition. Okay, so an example of this is 5 times 3 is equal to 3 times 5. Just to give you an illustration, if we have 1, 2, 3, 4, 5, 3 times, it is equal to, oops, let me kind of bring that down, 1, 2, 3 times 5. So we know that here we have a total of 15 circles, and here we have a total of 15 circles. Here on this side, we have 5 rows. On this side, we have 3 columns. Here we have 3 rows, and on this side, we have 5 columns. So 5 times 3 is the same thing as 3 times 5, where we get 15. Something to remember here is the commutative properties work only with addition and multiplication. They do not work with subtraction and division. So let me write that down for you. The commutative properties work only with addition and multiplication. They do not work with subtraction and division. So a very important note for you to make there, okay? Make this a bullet point. Now let's talk about another property, the associative property of addition and the associative property of multiplication. These are a different pair of properties. So it tells us that when we are adding 3 numbers or multiplying 3 numbers, the order in which we group the numbers does not matter. What does that mean? Let's actually let's write that out. Associative property of addition states, so here's the law, that for any 3 numbers, whether it's number A, whether it's B, or C, here it is, A plus B plus C, it's the same thing as A plus B plus C. So here's the law. And that's the beauty about math, is that the properties or laws, they're written in this type of format here. It's not long words, which it can be written down like that, but at some point we should be able to look at this equation. We should be able to look at this equation and know that, okay, this is the associative property of addition, the law called associative property of addition. Let's look at some examples. 1 plus 2 plus 5 can be calculated either as 1 plus 2 plus 5, which if we look here, 1 plus 2 would be 3. Then we have 5, which is equal to 8. Or it can be calculated as 1 plus, now we're going to add them a little bit differently, 2 plus 5. So now we're taking that guy, those two, and bringing them down here. Will they equal the same thing? Let's find out. We know we're going to bring 1 over, right? And then we're going to add 2 and the 5 together, which is equal to 7. And we know that 7 plus 1 is equal to 8. And look at that. They equal the same thing, even though that those 3 numbers have been moved around or added in a different order. Still gives us the same result. So the grouping doesn't matter. The sum is the same. Remember that. Let's write that down. In associative, let me fix that. Associative property of addition, the grouping doesn't matter. The sum is the same. Now let's look at another one. The associative property of multiplication states that for any three numbers, A, B, and C, the following is true. And what is true? That A times B times C is equal to A times parentheses, open parentheses, B times C, close parentheses. So an example of that is, let's say that A is equal to 2, B is equal to 3, and C is equal to 5. So if we plug those numbers into the law, they should match. If we plug these numbers in, right, whatever this combination equals should be what this combination of multiplying these numbers equal. So let's test that out. Clean that up for you. So 2, you can see there, right? A is 2 times 3, because B equals 3, times C, and C equals 5. Then we have A over here, which A equals 2 times, open parentheses, 3 times C equals 5, close parentheses. So now let's actually multiply these numbers in order and see if both sides of the equal sign are the same. 2 times 3 equals 6. Bring down the 5. 6 times 5 equals 30. Okay, now let's do this side. Let's bring down the 2 times 3 times 5 equals 15. And 15 times 2 is also equal to 30. You want to double check that? See, 5 times 2 is 10. 2 times 1 is 2, plus the 1 on top, that is 30. So, lo and behold, we just proved that the associative property of multiplication is true. This law is true. That's the beauty behind math. You're given these laws, you can plug in the values, and you can verify that the law is true. Okay? So again, just like in the commutative property of addition multiplication, grouping doesn't matter. The product is the same. So let me write that down for you. Feel free to type these notes or write these notes in as well, or even take pictures and share with a friend if this is helping you out. If you're finding this video is helpful, please make sure to like and subscribe. And if there's anything you want to add on to help your fellow classmates or friends watching this channel, make sure to add that in the comments below. The grouping doesn't matter. The product is the same. So the associative properties work only with addition and multiplication. They do not work with subtraction. The associative properties work only with addition and multiplication. They do not work with subtraction and division. So you might be thinking or asking, what's the difference between commutative properties and associative? I'll bring the screen down. Don't worry. Here we go. What's the difference? Well, commutative relates to the order of the numbers, while associative relates to the grouping of the numbers. Very good notes here. Hope you're taking advantage of this. Moving on. Now let's look at the distributive, let me fix that for you, property of multiplication over addition. So do me a favor and think distributive means to share or give out. Yeah. Distributive means to share or give out. And this law says that we get the same number when we multiply a group of numbers added together, or when we multiply each number separately and then add them. I'll fix that. Sorry. Gotta love that quick correction there. So the distributive property, it can be used when multiplying a number by the sum of two numbers. So for example, let's say we have A, B, and C. The law says that A, open parentheses, B plus C is equal to A times B, close parentheses, plus open parentheses, A times C. So what's happening here is that we've distributed this A to the values inside of the parentheses. We're distributing the term to each of the terms B and C. Let me actually draw that out for you. So we have A. Add some arrows. It's going to make a lot of sense. Give me one moment. Open parentheses, B plus C. And I'm going to add a red arrow. Now a green arrow. So this is equal to A times B plus A times C. We're distributing the term A, this term, into the terms inside of the parentheses. So let's do an example here with the distributive property. Let's do an example. We're going to first expand, and then simplify. So we have 3 times 6, we have 3, open parentheses, 6 plus 8, close parentheses. So if we expand that, or distribute, we'll get, so remember the arrows, right? 3 times 6. We have our plus, we're going to bring that over. And then 3 times 8. And so this is expand. Now we're going to simplify. 6 times 3 is 18, plus 8 times 3, which is equal to 24. And 18 plus 24 is 8 plus 4 is 12. And then 2 plus 1 is 3, plus 1 is 4. 42. And if you were to punch this into your calculator, you would get 42. So we talked about the distributive property of multiplication over addition. Now you might say, what do you mean over addition? I might have forgotten to explain that. Over addition because there's an addition sign inside of the parentheses. But what happens if it's not an addition and it's a minus? Will this law still stand? And what would the law be called? Well, that law is called the distributive property of multiplication over, you guessed it, subtraction. And it says that we get the same number when we multiply a group of numbers subtracted together, or when we multiply each number separately and subtract them. So an example of this law is given 3 numbers, A, B, and C. The law is A, or the property looks like this. A, open parentheses, B minus A is equal to, open parentheses, A times B minus A times C. Why? So, let me draw the arrows for you again. A times B minus A times C. Make that green. This is the distributive property of multiplication over subtraction. So the beautiful thing is the distributive property can also be used for expressions with multiple terms. So for example, we have, let's say we have A, open parentheses, B plus C minus D. What would that look like? So let me do my arrows. Plus C minus D is equal to, it's the same thing. We start off with red arrows, A times B plus A times C plus, oops, and let me correct that, minus, because we have a minus next, right? Minus A times D. That would be equal to AB plus AC minus AD. So just so you know, in mathematics, you don't always have to write the dot or multiplication sign. between the two terms, it is understood or known when two terms are beside each other, you are multiplying. So we have just expanded this using the distributive property of multiplication. So why don't we actually use some numbers here, okay? Let's simplify 6, open parentheses, 2 minus 1 plus 5. Let's follow our arrows. We know that this would be equal to 6 times 2. I'm going to bring that negative over, minus 6 times 1. Bring the plus sign over. 6 times 5. We know that 6 times 2 is equal to 12, minus 6 times 1 is equal to 6, plus, because we're bringing the plus side down, 6 times 5 equals 30. We know that 12 minus 6 is equal to 8. Sorry, 12. And we know that 12 minus 6 is equal to 6, plus bring our 30 down, right? And 6 plus 30 is equal to 36. So we just found the answer. We just simplified by using the distributive property of multiplication. So why don't we do some practice? And I'll provide the answers, okay? For questions 1 through 4, state the property used. 1, 3 times 5 equals 5 times 3. Put your answer there. 2 plus b in parentheses plus 1 over 2 is equal to a plus open parentheses b plus 1/2 close parentheses. What's the property used there? 3, 1 over 2 open parentheses 5 times 4/3 equals open parentheses 1/2 times 5 close parentheses times 4/3. 4, 0 plus 5 is equal to 5 plus 0. Now, for problems 5 through 6, state whether or not the property is being applied correctly. 1 over 2 divided by, let me fix that, it doesn't look too clean, divided by 7 is equal to 7 divided by 1 over 2. If you were to use the associative property for this, has it been done correctly? Yes or no? For 6, use the associative property to state 7 plus 3 minus 1 can be calculated as 10 minus 3 minus 1, or 10 minus open parentheses 3 minus 1. Is that true or false? Yes or no? For questions 7 through 10, use the distributive property to expand each expression. then simplify your answer. So for 7, 2, open parentheses, 3 plus 8. For 8, do 5 times n minus m times 12 is equal to mn minus 12m. For 9, do 4, open parentheses, 10 minus 2 plus 5, and 10 do x times y minus x times z plus x times 3 is equal to xy minus xz plus 3x. Is that true? So instead of me here, this might help. Let me just bring this over and I'll shrink that for you just a little bit. Here we go. Is that true? Does this equals that? Or does this equal this? Is it the same thing? Pause the video and we'll solve it together. Hopefully you had time to work on the practice problems. Remember, I want to encourage you, the more you practice, the more you're going to get better at this. Even myself, if I just watch videos all day and I don't actually do some problems, the learning is not as efficient. So be encouraged when you do these problems. You want to do problems now while in practice mode, so when test day comes, you can pass. So starting again with the first one, for questions 1 through 4, state the property used. So in this example, the commutative property of multiplication is being used. Remember that commutative has to do with the order. So in commutative property of multiplication, you are just changing the order from 3 times 5 to 5 times 3 equals the same thing according to that property. And then here, what's being used is the associative property of addition. Remember, associative has to deal with grouping. So on the left side of the equation, we have a plus b in parentheses. But on the right side of the equation, the group changed. And it's now b and now the grouping is changed, and now it's b plus 1/2 in parentheses, which is true according to that property. In this example, for number 3, the associative property of multiplication is being used. Okay, just the grouping changes here. We have 5 times 4/3 being multiplied in the parentheses, but the grouping changes on the right side of the equation. We have 1/2 times 5. For number 4, the commutative property of addition changes. Okay, commutative relates to the order. So on the left side of the equation, the order is 0 plus 5, but on the right, they just switch it over to 5 plus 0. Still equals the same thing. 0 plus 5 is 5, and 5 plus 0 is 0. True. For problems 5 through 6, state whether or not the property is being applied correctly. So in this example, 1/2 divided by 7 does not equal 7 divided by 1/2. Something to keep in mind, remember, associative and commutative property does not work with division. We learned that earlier and we actually wrote it down. Here, 7 plus 3 minus 1, they rewrote it as this expression and this expression, which both are incorrect. The expression results are different answers. So for questions 7 through 10, use the distributive property to expand each expression, then simplify your answer. So here we started off with this expression, right? And we are going to distribute, which we did. I did 2 times 3 here, and then 2 times 8 here equals, and we know that 2 times 3 equals 6, and 2 times 8 equals 16, equals 22. Here we have m times n minus m12. Well, we simplified that by just pretty much removing the parentheses. And earlier I taught you that in mathematics, you don't need the multiplication symbol of x or dot or parentheses to signify a multiplication. If the variables are right beside each other, it is known that they are being multiplied. Minus 12m. So we did the same thing. We just pretty much brought the 12 to the front and put the m right beside it. It's more formal. Oops. Sorry, I don't know why my screen does that. It's more formal. In mathematics, it's more formal to put the number first and then the variable. But if you don't, it's still right. But if you don't, it's still right. Okay, last one. How do we simplify this? Well, just simply remove the parentheses or distribute. X times y is xy minus, bring the minus over. X times z is xz, bring the plus over. X times 3 is 3x. Okay, this was a jam-packed lesson. I hope you took much notes and you enjoyed the practice. On the next video in the series Math for Beginners, we will be doing Unit 1, Chapter 3, Order of Operations. See you on the next one.